Number 10 is the integral from 0 to 2 of x e to the x squared dx. So the first thing we want to do is figure out what u should be. Again, if it's e raised to a power, u should be that power. So u is going to equal x squared. Well, if u is equal to x squared, then the derivative du would be 2x dx. But I don't have a 2x dx, I only have an x dx, so I need to divide out my 2 from both sides. So 1/2 du is equal to x dx. Then I'm going to change my limit of integration. So my new upper limit would be, well, the current limit is x equal 2. So we would have u is equal to 2 squared. Therefore, u is equal to 4. My new lower limit, so it's currently x equals 0. So I would say u is equal to 0 squared. So my new lower limit is equal to 0. So we're looking at the integral from 0 to 2 of e to the x squared times x dx. So this becomes the integral from 0 to 4 of e. Remember, x squared is actually u. And my x dx is 1/2 du. Well, the integral of e to the u du we know is going to equal e to the u, and this gets evaluated from 0 to 4. So this is going to be 1/2 e to the 4th minus 1/2 e to the 0 power. Now I know that e to the 0 is equal to 1, so this is going to be 1/2 e to the 4th minus 1/2. Or in a calculator, if I want to find the approximate answer, this is going to equal, well, 1/2 times e raised to the 4th power minus 1/2 to 3 decimal places is going to be 26.799. Let's look at number 11. Again, the first thing I want to do is I need to figure out what u should be. Well, since 2x squared plus 4x plus 4 is in the denominator, I'm going to let u equal my 2x squared plus 4x plus 4. If u is equal to 2x squared plus 4x plus 4, then the derivative du would equal 4x plus 4 dx. But I don't have a 4x plus 4 dx. I only have an x plus 1 dx, so I can divide the 4 out of those terms. So I end up with 1/4 du is equal to x plus 1 dx. Let's change those limits of integration. So the current upper limit is x equal 2. So my new upper limit, so if we have x equal 2, we know that that would be u is equal to 2 times 2 squared plus 4 times 2 plus 4. So in a calculator, we would write 2 times 2 squared plus 4 times 2 plus 4, and we get that our new upper limit is equal to 20. My new lower limit, well, my current lower limit is 1. So this is going to be u is equal to 2 times 1 squared plus 4 times 1 plus 4. And again, in a calculator, we would end up with u is equal to 10. So now, if I look at the original problem, it was the integral from 1 to 2 of 1 over 2x squared plus 4x plus 4 times that x plus 1 dx. So it becomes the integral from, the new lower limit is 10, my new upper limit is 20, And then I have 1 over 2x squared plus 4x plus 4 is equal to u. And my x plus 1 dx is equal to 1/4 du. Well, I know the integral of 1 over u du is going to equal the natural log. So this is going to equal 1/4 times the natural log of the absolute value of u evaluated from 10 to 20. Now, if we move over here to finish this off, we're looking at 1/4 times the natural log of the absolute value of 20 minus 1/4 times the natural log of the absolute value of 10. Now notice these both have 1/4 in common. So this is going to be 1/4 times the natural log of 20. And I don't need absolute value bars around it because 20 is a positive number. Minus the natural log of 10. And since the bases are the same, since this is both the natural log and we're subtracting, we're allowed to rewrite this as a quotient. So 20 over 10. Therefore, this is the same as 1/4 the natural log of 2. Or you can try to determine what this is in a calculator. And in a calculator, 1/4 times the natural log of 2 is going to be approximately 0.173. So approximately 0.173. So 1/4 the natural log of 2 or approximately 0.173. And again, when you're doing these problems, you'll either have the exact answer or the approximate answer, depending on what they're requiring of you. Now, the next thing that we're going to look at is the average value of a function. So the average value of a function is, if you take the function from the interval from a to b, so what is the average y value that you're typically getting there? So suppose f is an integrable function on the interval ab. Then the average value of the function f on that closed interval ab is equal to 1 over b minus a times the integral from a to b of f of x dx. So let's go ahead and use this formula to find the average value of a function over the indicated interval. So in this case, my a is equal to -2 and my b is equal to 3. So if I want to find the average value of my function f of x over this interval, it would be 1 over b, which is 3, minus a, which is -2, times the integral from a, which is -2, to b, which is 3, of f of x, which is my 4 minus x squared dx. Well, if I clean this up, 3 minus a -2 is 3 plus 2, which is 5. And if I integrate this, well, the integral of 4, remember this is just k is equal to 4, is going to be 4x. And here my n is equal to 2. So this is going to be minus 1 over 3x cubed. And this gets evaluated from -2 to 3. So if I evaluate this, we're looking at 1/5 times, and this is going to be 4 times 3 minus 1/3 times 3 cubed, and that's minus lower limit of integration 4 times -2 minus 1/3 times -2 cubed. So plugging that into a calculator, we get 1/5 times, and then it's going to be 4 times 3 minus 1/3 times 3 to the third minus 4 times -2 minus 1/3 times -2 to the third. And we end up with 1.6 repeating, which if we make into a fraction is 5/3. So the average value of this function from -2 to 3 is going to equal 5/3. Let's look at number 13. Number 13 is more of the same. It wants you to find the average value of the function of g of x is equal to the square root of x plus 1 over the interval from 3 to 8. So in this case, my a is equal to 3 and my b is equal to 8. So the average value of my function is going to equal 1 over b minus a times the integral from a to b of f of x, or g of x in this case, dx. Well, the first thing I'm going to do is I'm going to rewrite this square root in something that I like to handle, and I'm going to go ahead and simplify this fraction over here. 1 over 8 minus 3 is 1 over 5 times the integral from 3 to 8, and this is going to be x plus 1 to the 1/2 dx. Well, in order to solve this, I have to use u substitution. So if I let u equal what's raised to a power, so if I let u equal x plus 1, then my derivative du is going to equal 1 dx. Perfect, that's what I have. I'm going to go ahead and change my limits of integration. So my new upper limit, well, currently it's x is equal to 8, so it's going to be u is equal to 8 plus 1, or 9. And my new lower limit, well, my current lower is x is equal to 3. Therefore, we're looking at u is equal to 3 plus 1. And 3 plus 1 is going to equal 4. So this here is going to become 1/5 times the integral from lower limit of 4 to upper limit of 9 of x plus 1, recall, is u raised to the 1/2 power, and my dx is just my du. Well, I know how to integrate that. That is going to equal 1/5 times 1 over, well, here my n is equal to 1/2, so 1/2 plus 1 is 3/2, so that's going to be 1 over 3/2 u to the 3/2, and this is evaluated from 4 to 9. So let's clean this up. If in a calculator I figure out what 1/5 times 1 over 3/2 is, I'm going to end up with 2/15. So this is going to be 2/15, and then it's going to be u to the 3/2 evaluated from 4 to 9. So plugging in my upper limit of integration, I get 2/15 times 9 to the 3/2 minus, plugging into my lower limit of integration, I get 2/15 times 4 to the 3/2. So in a calculator, if I'm trying to determine what that is, so I'm going to get 2/15 times 9 raised to the 3/2 minus 2/15 times 4 raised to the 3/2. Hit enter and I get 2.533. So let's go ahead and make that a fraction. So we hit math and enter twice, and I get 38/15. So the average value of that function of the square root of x plus 1 from the interval from 3 to 8 is 38/15. That's it for section 5.5.